All right, welcome back to another network automation video. We're going to be moving forward. Unfortunately, we had some problems getting the Ansible examples to work. I'm just going to skip it. I think, obviously I'll need to figure it out if things get more advanced, but for now, I just want to continue to read. So these are advantages Ansible has over other ways of configuration, such as PyEZ, PyEAPI for Arista, Paramiko, even pexpect, NetMiko, or Nornir. So one of the advantages, so I'll go through the advantages I already went over. So one is that it's agentless, which I don't understand why that's an advantage. Like, I don't understand why, because these are, oh, I see. Okay, so this isn't an advantage that Ansible has over Nornir, Paramiko, anything like that. This is an advantage it has over other automation frameworks. So there's Puppet, there's Chef, there's SaltStack. These are other automation frameworks you can take advantage of, but you're better off taking advantage of Ansible in the eyes of this author because Ansible is agentless. You don't need to install any sort of client software on the devices you want to manage. It has idempotence. If you were to reconfigure a device, those changes would only be sent if they were needed and had not already been applied. And it's simple and extensible. Ansible is written in Python and uses YAML for the Playbook language, both of which are considered relatively easy to learn. Remember the Cisco iOS syntax? This is a domain-specific language that is only applicable when you are managing Cisco iOS devices or other similarly structured equipment. It is not a general purpose language beyond its limited scope. Luckily, unlike some other automation tools, there is no extra domain-specific language to DSL to learn for Ansible because YAML and Python are both widely used as general purpose languages. Oh, okay, so DSL, they mean domain specific language. I guess they never, oh, I see, okay, this is where they're doing it. It's just kind of clumsy. I wish they would put it in parentheses. That would make it easier for me to understand that they're abbreviating domain specific language through the acronym DSL. As you can see from the previous example, even if you have not seen YAML before, it is easy to accurately guess what the playbook is trying to do. Ansible also uses Jinja 2 as a template engine, which is a common tool used by Python web frameworks such as Django and Flask, so the knowledge is transferable. I cannot stress enough about the extensibility of Ansible. As illustrated by the preceding example, Ansible starts off with automating server, particularly Linux, workloads in mind. Then it branches out to manage Windows machines with PowerShell. As more and more people in the industry started to adapt Ansible, the network became a topic that started to get more attention. The right people and team were hired at Ansible. Network professionals started to get involved and customers started to demand vendors for support. Starting with Ansible 2.0, network automation has become a first-class citizen alongside server management. The ecosystem is alive and well with continuous improvement in each of the releases. Just like the Python community, the Ansible community is friendly and its attitude is inclusive of new members and ideas. I have firsthand experience of being a noob and trying to make sense of contribution procedures and wishing to write modules to be merged upstream. I can testify to the fact that I felt welcomed and respected for my opinions at all times. the simplicity and extensibility really speak well for future proofing. The technology world is evolving fast, and we are constantly trying to adapt to it. Wouldn't it be great to learn a technology once and continue to use it, regardless of the latest trend? Obviously, nobody has a crystal ball to accurately predict the future, but Ansible's track record speaks well for future technology and adaptation. I'm kind of like, I don't know if I can let go not having those examples work, because we're really, I think, kind of missing a lot of the points that this book is making about how kind of effortless it works with other servers. So I kind of want to get a better sense for that, and I think it's just a matter of it of it being able to go into that etc Python folder. So I'd like to get that to work somehow. Looks like I'm having that error where if I leave this running for too long, it needs a reboot. So I'll do that, and then I think I'm gonna try to download Python 2.7 onto this Ubuntu server here, and hopefully that will make it so that this example works. I really kind of don't feel right just skipping over the examples without having them work, because I just don't think the exercises are going to be as, or I don't think the rest of the book is going to be as valuable if I kind of just skip over whenever I have a problem. So fortunately, it's kind of a situation where in order to get the stuff to work, you have to already know how to get them to work. But I think, I've used Ansible before, and this, I think I can get this to work. So let's do it. So we got to wait for it to boot up. Let's move the bookmark ahead to network vendor support. And then whenever things are downloading, we can continue to read on in the book. So right now we're just waiting for the system to, it is boot up. So let's get that Python 2 download going. And then we'll try to go through the Ansible examples that unfortunately I was not able to get to work. So we'll see if I can figure that out this time around, now that I'm a bit more energetic. So let's do a ls. Or let's do a sudo apt-get install Python 2. So, yep, this looks good to me. Oh, it looks like 5 meg of space is going to be used. That's fine. Could not resolve, so maybe we've got issues with internet connectivity. We do. So let's figure out what's happening with that. Oh, we've got ENS4 is on, but you can see we're getting that glitch where if you turn one interface on, the other one goes off, but it's not going to be a big deal. Oops. But we will want, let's see here. So I'll click apply on that. Turn this one on. There we go. And then that's going to be interface 0. So this is -2. So -2, 0. So it looks like the cabling's wrong. Yeah, so 0 will go up to the cloud here, and then 1 will go over to the other server. Perfect. So now hopefully we've got connectivity to the public internet. We can test that real quick. This is the Google DNS servers. Oops, still network is unreachable. Right, we're gonna have to remove the connection profile. All right, and now set it up for DHCP. All right, so now hopefully things will work better. There we go. So let's install Python 2. All right, Python 2 is installed. So now let's try to run those examples again. Okay, so we've got public key authentication, looks good. So let's move on to the next step, which is going to be this inventory file. So we're going to do cd etc Ansible cat hosts. Perfect. I bless. Okay. So let's take a look again at what the IP is on here. We'll have both of them open up. So we will need to configure the, and we can only have one up because of a bug. I don't know if it's because of the fact that I'm using a different kind of terminal. I mean, I wouldn't think a terminal would have to do with that. But let's use the IP, the same IP addressing that is in the book. So it's going to be 192.168.2.122, and they don't have the subnet mask there. Let's just make it a /24. Oh, and it's .2.122. All right, so let's configure the other device so that it can connect to that. So let's try ping 192.168.2.122. You'll see we don't have a network for that. We don't have a directly connected network because we don't have it configured on an interface. And not only that, if I do a route, you can see we don't have a gateway of last resort. So let's configure that interface that goes to that device. All right, and it's going to be, let me double check which one. So -1, so it's going to be ENS2, which I think it's going to be 3 more than that, so it'll be ENS5. Yep, right here, ENS5. So let's configure that. (192.168.2.1). Perfect. So everything looks good configuration-wise. Let's make sure that we can ping before moving on. Oops, and we cannot, which is interesting. Can we ping ourselves? Cannot. Okay. Oh God, there's like a, there's like a bug in my hair or something. I don't see where it went though. All right. Let's see here. So, oh, okay. So here's ENS5. So it should be a directly connected route on there. Oh, there's the bug. Well, oh, it's a weird looking bug. I'm still kind of new to living in Texas, so all the bugs down here are a bit different than when I used to live in Wisconsin. I'm gonna go take care of it. All right. All right, so we're back at it. Let's make sure that so this is ENS5. So, I see. Whenever you add a new IP in this version of Linux, I don't know, because it's a VM or something, you've got to remove the connection profile first. Otherwise, it won't overwrite the existing one. So 192.168.2.1. Yeah, that always trips me up, but luckily it's just as easy as doing that. Really not hard. There's a way to do it via the CLI as well, but I found the GUI was a bit easier. Okay, so, well, I guess I spoke too soon because it's not quite working yet. Now it looks like I can't even, oh, okay, here we go. Perfect. So ENS5. So hopefully, yep, it's got 192.168.2.1. And it's got a subnet mask. It's a wired connection. Yeah, everything looks good. I guess I'm surprised it can't ping itself. Oh, it can now. Okay, sweet. All right. So it just took a little bit of time for it to like come up. So let's see if we can hopefully do those exercises now. So this is going to be a file we're going to need to add to that host file. So by hosts, and we can just get rid of these. So 3D enter, oops. Oh, and it's a read-only file. So let's get out of here, come back in with the appropriate permissions. Need a password to do that. And one thing that's kind of interesting about using by 3D enter removes 4 lines. And in this case, it looks like it removed them from an area I did not intend for them to be removed. There we go. Yeah, I think there's like 3 modes. There's control mode, there's input mode, and then there's like colon mode. All right. So yeah, one of my bucket list goals, as I've talked many times on here, is be able to sit down and buy and go, woo, you know, really use it really well. But as long as I can accomplish my goals, it's really accomplishing them as fast as possible isn't always my goal. It's just to accomplish them. All right. Perfect, especially if I can accomplish them by the deadline. All right, so let's do this now. Ansible-I hosts. Oops. So we're missing some arguments. We need 192.168.2.22 dash. Aha, so yep, now that we went and fixed the network connection, I think it wasn't wired up properly. We installed Python 2.7 on there, so now it's got this folder. So, oh yeah, and we got a deprecation warning, but we did get back to the discovered interpreter, and then we got ping, we got Pong in our response to ping. So we're good to use Ansible. Let's see if we can get the next exercise to work. Okay, so let's make a playbook. So do cat df playbook, because I should already have it. It's going to be in my home folder here. So we'll need to use a different IP. It's going to be what the book is using. So it's going to be 192.168.2.122. WQ, perfect. Don't need. We don't need elevated permissions for that because it's just a file. It's not in a special folder. So Ansible playbook host df playbook.yaml. Oops, so there is a problem here. Let's read the error message. Unable to parse. Aha, so we gave it the wrong. So if you can see by default, it has the wrong inventory source. So let's give it the full source. And now hopefully we won't have those same kinds of issues. Aha, so it looks like we've got a syntax error while loading the YAML. Did not find expected dash indicator. The error appears to be there, column 2, but maybe somewhere else. So, aha, so yeah, it looks like this book has a typo in it. It says that you can just write shell, you don't need a dash, but you're gonna need a dash. So let's add that. Yeah, I'm surprised you wouldn't need one for tasks too. I'll add one. All right, let's see if it works. So, oops, so the offending line, let's see here what this says now. So it says, shell is not a valid attribute for a play The error appears there. Okay, so shell is not a valid attribute. That's interesting because they're saying that it is. Okay, so that's interesting. Let's look more at, so let's go into the mastering Python repo here. And then this is, I think, chapter 3. Actually, no, I think it's chapter 4. So yeah, here's DF Playbook. Let's see what they've got here, because there might be just something looking strange in the, oh, and it's not going to be, yeah, so it's DF, the YML. Okay. Oh, I see. Yeah. So there's special pace spacing, all that sort of thing. So let's open up another terminal and then use this for a guide to understand what we need in that file. So vi, and then this is DF Playbook. Perfect. Okay, so now you need a blank line down here. You need that to be indented. Oh, no, actually you don't need this to be indented. Perfect, but you do need this to be indented. And then the shell doesn't need a dash. Okay, so yeah, everything I think looks good. Let's give it a shot. Perfect, works now. Now we've got a valid playbook. So that syntax of the playbook is really important. So we've got our play to our target, then we've got our task, gathering facts, tasks, check disk usage, and there's a Playbook gap. I guess I don't see the disk usage. It'd be nice if I could see that. Okay, well, I don't see the disk usage. Let's cat that out. So, yeah, it just shows the, okay. So, okay, well, it's just gonna save it to a file. It's not gonna show us the disk usage in this version. So yeah, if you log into the managed host, in this example, you will see that the file contains the output of that command. So let's do that just to verify. There it is, and there's the output of the command. So yep, really nice and useful, a lot of verbose, useful output that you get. There's a pretty big advantage over something like Paramiko, where all of that output you've got to code yourself. So if that's the right output and it works for you, hey, you just saved yourself, you know, at minimum 5 hours of programming, but probably a lot more than that. All right, so let's see if there's any more examples. Nope, so that was the only example and we got it to work. So let's jump to the bookmark we were at. Well, doing that's kind of hard. I don't think it was that far forward, unless I can, let's see, trick it by going like this and then like that. I can, sweet, okay. Let's go to location, there we go. So network vendor support. Let's face it, we don't live in a vacuum. There is a running joke in the industry that the OSI layer should include a layer 8 money and layer 9 politics. Every day, we need to work with network equipment made by various vendors. Take API integration as an example. We saw the difference between the pexpect and API approach in previous chapters. API clearly has an upper hand in terms of network automation. However, the API interface does not come cheap for the vendors. Each vendor needs to invest time, money, and engineering resources to make the integration happen. The willingness of the vendors to support a technology matters greatly in our world. Luckily, all the major vendors support Ansible, as clearly indicated by the ever-increasing available network modules. So let's see if Extreme Networks supports it. I've had experience on Extreme Networks. Yep, even supported by big fat purple Extreme Network equipment. It's all purple. That's the only. So yeah, let's look at the purple routers. Are these not purple? Seriously? They had one job, Extreme Networks, was to make purple routers. And they did it for a long time, but it looks like they've moved on. Well, that's too bad. They're black now. Well, at least their switches are still purple. All right. Well, anyway, that's definitely a sidetrack, so let's get back to the reading. Why do vendors support Ansible more than other automation tools? Being agentless certainly helps, since having SSH as the only dependency greatly lowers the bar of entry. Engineers who have been on the vendor side know that the feature request process is usually months long and many hurdles have to be jumped over. Anytime a new feature is added, it means more time spent on regression testing, compatibility checking, integration reviews, and much more. Lowering the bar of entry is usually the first step in getting vendor support. The fact that Ansible is based on Python, a language liked by many networking professionals, is another great propeller for vendor support. For vendors such as Juniper and Arista, who have already made investments in PyEZ and PyE API, they can easily leverage the existing Python modules and quickly integrate their features into Ansible. As you will see in Chapter 5, the Python Automation Framework, Beyond Basics, we can use our existing Python knowledge to easily write our own modules. Ansible already had a large number of community-driven modules before it focused on networking. The contribution process is somewhat baked and established, or as baked as an open source project can be. The core Ansible team is familiar with working with the community for submissions and contributions. Another reason for the increased network vendor support also has to do with Ansible's ability to give vendors the ability to express their own strengths in the module context. We will see in the coming section that besides SSH, the Ansible module can also be executed locally and communicate with these devices by using an API. This ensures that vendors can express their latest and greatest features as soon as they make them available through the API. In terms of network professionals, this means that you can use the cutting edge features to select the vendors when you are using Ansible as an automation platform. We have spent a relatively large portion of space discussing vendor support because I feel that this is often an overlooked part of the Ansible story. Having vendors willing to put their weight behind the tool means you, the network engineer, can sleep at night knowing that the next big thing in networking will have a high chance of Ansible support, and you are not locked into your current vendor as your network needs grow. Now that we've covered the advantages of Ansible, let's explore its architecture. The Ansible architecture consists of playbooks, plays, and tasks. Take a look at df_playbook.yml that we used previously. So it looks like the playbook. So this will give us a clue into the indentation problems we had before, where it couldn't run until we put name and shell in a nested hierarchy under tasks. So it looks like the playbook starts with these 3 dashes, and then within that, you've got the play. So that's indicated by a dash, and then you've got hosts, tasks, and then of course your task is what you have indented under your tasks. The whole file is called a playbook, which contains 1 or more plays. Each play can consist of 1 or more tasks. In our simple example, we only have 1 play, which I gotta move these controls up here. Okay, sweet. We only have 1 play, which contains a single task. In this section, we will take a look at the following components and terms related to Ansible, some of which we have already seen. YAML, this format is extensively used in Ansible to express playbooks and variables. Inventory, the inventory is where you can specify and group hosts in your infrastructure. You can also optionally specify host and group variables in the inventory file. Variables, each network device is different. It has a different hostname, IP, neighbor relations, and so on. Variables allow for a standard set of plays while still accommodating those differences. Templates. Templates are nothing new in networking. In fact, you are probably using one without thinking of it as a template. What do we typically do when we need to provision a new device or replace a return merchandise authorization, RMA? We copy the old configuration over and replace the differences, such as the hostname and the loopback IP addresses. Ansible standardizes the template formatting with Jinja 2, which we will dive deeper into later on. In Chapter 5, the Python automation framework, beyond basics, we will cover some more advanced topics such as conditionals, loops, blocks, handlers, playback roles, and how they can be included with network management. I don't consider those advanced topics, not in Python, but I guess as they relate to Ansible, yeah, those aren't going to be things you'll typically do in a playbook, so they're more advanced topics. YAML is the syntax used for Ansible playbooks and some other files. The official YAML documentation contains the full specifications of the syntax. Here is a compact version as it pertains to the most common usage for Ansible. A YAML file starts with 3 dashes. White space indentation is used to denote structures when they are lined up, just like Python. Comments begin with a hash sign. List members are denoted by a leading hyphen with 1 member per line. The lists can also be denoted by square brackets with elements separated by a comma. Dictionaries are denoted by key value pairs with a colon for separation. Dictionaries can be denoted by curly braces with each elements separated by a comma. Strings can be unquoted, but can also be enclosed in double or single quotes. As you can see, YAML maps well into JSON and Python data types. If I were to rewrite df underscore playbook.yaml in df underscore playbook.json. This is what it would look like. This is obviously not a valid playbook, but serves as an aid in helping to understand the YAML formats when using the JSON format as a comparison. Most of the time, comments, lists, and dictionaries are what you will see in a playbook. Inventories. By default, Ansible looks at the etc Ansible hosts file for, well, not in our case. We saw it looked at home GNS3 hosts file. For hosts specified in your playbook, as mentioned previously, I find it more expressive to specify the, oh, I see. So if you do the -I, then you specify where it is, and we were giving it a relative path, not an absolute path. So without that -I option, it would have worked. I'm actually going to go back and demo that because that actually, I think, made it a bit needlessly confusing using that -I. So I'm just going to show that it's simpler than the author was making it. So if I just do this, yep, see how easy that is because my host file is in the default location. If I were to use the -I flag, I could use a host file anywhere I chose. It didn't even have to be named hosts. So, oops. There we go. So continue to read. Inventories. By default, Ansible looks at the, yep. I find it more expressive to specify, yep. This is what we have been doing up to this point. To expand on our previous example, we can write our inventory host file as follows. So, oh yeah, because they're using extra Nexus switches. They're using, yep, so they're using more stuff. As you may have guessed, the square bracket headings specify group names. So later in the playbook, we can point to this group. For example, in Cisco_1 and Cisco_2, I can act on all of the hosts specified under the Nexus group to the group name of Nexus. A host can exist in more than one group. The host can also be nested as children. In the previous example, the data center group includes both the Cisco and Arista members with 4 total devices. We will discuss variables in the next section. There are a few places you can declare your variables. In fact, you have already seen some usage of it. In our first inventory file example, we have declared variables both for hosts and groups in the inventory file. Nexus:* specifies variables for the whole Nexus group. The Ansible host variable declares variables for each of the hosts on the same line. For more information on the inventory file, check out the official documentation. Variables, as we discussed, so we discussed variables a bit in the previous section. Why do we need variables? Because our managed nodes are not exactly alike. We need to accommodate the differences via variables. Variable names should be letters, numbers, and underscores, and should always start with a letter. Variables are commonly defined in 3 locations: the playbook, the inventory file, separate files to be included in files and roles. Let's look at an example of defining variables in a playbook, Cisco_1.yaml. In the playbook, you can see the CLI variable declared under the var section, which is being referenced using the double curly bracket in the task of NXOS SNMP contact. For more information on the NXOS SNMP contact module, check out the online documentation. To reference a variable, you can use the Jinja2 templating system convention of a double curly bracket. You don't need to put quotes around the curly bracket unless you are starting a value with it. But I typically find it easier to just always put quotes around the curly brackets, so I do not need to think about the differences. You may have also noticed the inventory hostname reference, which is not declared in the playbook. It is one of the default variables that Ansible provides for you automatically. It references to the IP address or a DNS resolvable hostname in the inventory. Sometimes in the documentation, these variables are referred to as magic variables. There are not many magic variables, and you can find the list in the documentation. We have declared variables in an inventory file in the previous screen. To use the variables in the inventory file instead of declaring them in the playbook, let's add the group variables for Nexus by name in the host file. Then modify the playbook to match what we can see here in cisco_2.yaml to reference the variables. Notice that in this example, we are referring to the Nexus by name group in the inventory file, the Ansible host variable, and the username and password group variables. By offloading the username and password in a separate file, we make the file write protected with a better security posture. To see more examples of variables, check out the Ansible documentation. To access complex variable data that's provided in a nested data structure, you can use two different notations. Noted in the NXOS SNMP contact task, we registered the output in a variable and displayed it using the debug module. You will see something like the following during playbook execution. Ansible playbook -I hosts, so he's using it in his directory that he's in. Okay. In order to access the nested data, we can use the following notation as specified in cisco_3.yaml. You will receive just the value indicated. Lastly, we mentioned variables can also be stored in a separate file. To see how we can use variables in a role or included file, we should get a few more examples under our belt because they are a bit complicated to start with. We will see more examples of roles in Chapter 5, the Python Automation Framework, Beyond Basics. Okay, so I kind of want to get this to work. One thing I'm curious about is if they have any Cisco images that are not locked down behind a, like if I can sign up for a Cisco account. I mean, I already have one because I have search from Cisco. So like if there's something that they're offering here that will allow me to do similar things as in this book. So let's see here. So what kind of, okay, so they have Nexus routers in there. So let's add let's see if we can get a Nexus. Nope, no Nexus. Well, maybe they might not be routers, maybe they're switches. Aha, perfect. Yeah, it looks like we got it. So a Cisco NX. So I think that's what they're running. Let me double check. I think they're just gonna keep using the lab that they had before. It's way back. Yeah. Cisco NX OSV. So there's iOS and then there's an NX. And then But the thing is, that's not what they're using. Yeah, because they're using 172 addresses, so clearly that doesn't match. So they appear to be using Nexus devices. Let's see if we can get, oh, they actually are using Arista as well. But let's start with the first example and see if we can get that running. So first let's start by creating a host file that matches exactly what they've got there. So we can use that -i flag, and we can give it a custom host file anywhere on the device. We don't have to use the default host file. So let's make a new host file here, and then we can do a -i hosts, and it will know that it's a relative file path, and it will look in this directory as long as we're in it, and use this one instead of the default host file. All right, so we've got that host file. We don't have any of these. So we do have the Ubuntu machine here, but we don't have these Nexus devices set up. So let's see if we can get that going. So yeah, let's just get a Cisco NX OS. Okay, and then they're hopefully going to give us a link where we can download this without violating any kinds of user agreements or anything like that. So, yep, so it looks like in order to do that, you got to log into your Cisco account, which I do have. I think you can sign up for one for free. I signed up for one because you need one to get certs, and I've got the CCNP. All right, so now that we're logged in, let's try it again. Oops, and looks like there's no, there's nothing here. Their download link is unfortunately, oh, that's weird. I'm like, I wonder that if that'll show up in the final video. It's making my head kind of move in weird ways when I go. I don't know where it was, but anyway, well, that's too bad. Let's see if just clicking on the main part will, nope, you can't even download it then. Yeah, so unfortunately, there's no, there's nothing available through the official site. So one thing we can try doing is searching for it. Oh, yeah, I don't want to buy viral. I had thought about purchasing viral. Okay, but let's search for the image name. I gotta manage my windows though. So I gotta close this window here, open this one here, move it over to the side, click the magnifying glass. Now I can search for it. So let's search for NX OS V. What about okay, yep. So clearly they've got nothing. Oh, this is the Cisco Learning Network store. It's kind of a strange link. I wonder if there's like a downloads section, free downloads, anything like that. Certification training. Technology training, maybe like network programmability. Is there any free downloads or anything like that here? Trial version. No, I don't see anything. So, well, that's too bad. Maybe let's try the other one too, because there was also a Nexus 9000. So maybe we'll have more luck with that. And it's going to be a switch. Yeah, let's see if we get more luck with this. Aha, yeah, so it looks like we got a lot more options here. Oops, and the whole thing minimized using a key combination. I don't know. Oh, okay, here we go. There we go. So now we've got one of the files. We're just gonna need one more. There we go. So we're just gonna need this file now. So we're gonna need to be registered with the vendor, which I am. I'm already logged in. So here it is. And this is 9.3.1 QCOW image. Let me decline and make sure, oops, I've got to give a reason for declining. So let's see here. So encryption to apply for eligibility to download strong encryption software images. Conditions, downloading shall comply with all laws. Yeah. Not named. Yeah. Abide by all. Okay. Yeah. I mean, I'm just using it for civilian entity. And then I'm not sure which organization they're talking about, but I am definitely authorized to represent myself. So, all right. So what's the user agreement? How long is it, more importantly? It's 25 sections. Let's see if there's anything about like YouTube, not being able to put it on YouTube or something. I don't see anything. So this is an OVA, so that's not going to work. Oh, okay. So here's the Q cow down here for KVM. All right, so that was easy. I'm hoping this is legit, that there's some sort of, yeah, I suppose I could read the whole user agreement to kind of, well, let's see if there's any, yeah, let's see limitations and restrictions, because I definitely want to make sure, yeah, I'm not going to sell it. I'm not going to modify it. I'm not going to change the source code. Yeah, I'm not going to let anyone else use it but myself. Yeah, so I think this is legit. Yep, just a free download to learn more about this. So I think I can upload the other file now, or sorry, import, I mean. So it'll be in my downloads. Here it is. Oops, no, that's the partial. So I gotta unzip that first. Let's unzip that. It's gonna be in the downloads. And now we're gonna unzip this. Excellent. All right, perfect. Now we just got to get this QCOW, which is still downloading. It's a pretty big image. 4 minutes re-rating. So let's see if we can do any more reading or maybe move the bookmark up. Yeah, let's move the mark up to where I finished reading. Yep, and I believe it was here. So it looks like I think there's a trick where, yeah, I can resize it and now I can access everything. All right, so I think that's legit. I read over the user agreement. I didn't see anything saying you can't make an educational video on YouTube with it. And then my channel is not monetized yet. Not getting that kind of viewership. So it's, I don't think it's going to be a big deal. Yeah, we still got 3 minutes. 3 minutes is a long time. I'm kind of tempted to just can it here and then come back once it's done. I think I'm going to do that. I could use a break. So thanks for watching, and I'll see you in the next video.